This is SpaceTime, Series 23, Episode 29. Coming up on SpaceTime, the Voyager 2 spacecraft being affected by a major upgrade at NASA's Canberra Deep Space Communications Complex. A whole new generation of European launch vehicles about to take off. And NASA's new mission to study giant solar particle storms. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The Voyager 2 spacecraft's being affected by a major upgrade at NASA's Canberra Deep Space Communications Complex. The critical work is focusing on the facility's giant 70-metre radio dish. It means the 48-year-old antenna is expected to be out of service for at least 11 months. And the project will leave NASA's Voyager 2 spacecraft, which is quietly coasting through interstellar space, without being able to receive any commands from mission managers, although it will still be able to send updates and science data back to Earth. The work's needed because some parts of the antenna, including the transmitters that send commands to various spacecraft, are now more than 40 years old and increasingly unreliable. The upgrades are planned to start now that Voyager 2's been returned to normal operations after accidentally overdrawing its power supply and automatically turning off its science instruments back in January. The Deep Space Network is operated by NASA's Jet Propulsion Laboratory in Pasadena, California. It uses 3 primary ground stations spread evenly across the planet at Goldstone, California, Madrid, Spain, and the Tidbinbilla complex near Canberra. These allow NASA to communicate with its spacecraft around the Moon and beyond at all times during Earth's rotation. Voyager 2 was launched back in 1977 and is now more than 17 billion kilometres away, flying through interstellar space. It's travelling in a downward direction relative to Earth's orbital plane, so it can only be seen from the southern hemisphere, and thus can only communicate with the Australian site. Importantly, a special S-band transmitter is needed to send commands to Voyager 2, and the one at the Canberra Deep Space Complex is the only one powerful enough to reach interstellar space, and the only one on a frequency that can communicate with Voyager 2's data technology. The Canberra 70-metre antenna, called DSS-43, is the only one in the southern hemisphere. And as the equipment in the antenna ages, the risk of unplanned outages increases, adding more risk to the Voyager mission. The upgrades will not only reduce that risk, but will also add state-of-the-art technology upgrades that will benefit other missions, including the Mars Perseverance rover, which is slated to launch in July, and future manned Artemis missions to the Moon and Mars. Now, there are 3 34-metre dishes at the Canberra complex, which can be configured to receive transmissions from Voyager 2, but can't send. So mission managers have decided to place the spacecraft in a quiescent state, allowing it to continue sending data during the 11-month downtime. Glenn Nagel from the Canberra Deep Space Network Complex says the work's expected to be completed by January.
Yes, Deep Space Station 43, our venerable workhorse of the Deep Space Network, has been operating for nearly 48 years, in fact, and it's time for an upgrade. It's going to get an 11-month downtime to have repairs done to various systems, upgrades to its transmitters, and full electrical upgrades. There's a lot of work to be done over this next period.
Is this just a regular cyclic thing, or is this being done for special missions like Artemis and things like that?
So we do regular maintenance on the antennas. It's literally a week-to-week thing, and then every few years there might be replacements of major components. But this particular downtime has been in planning for at least the last 5 years to really put the antenna in a position so that it can be ready for future missions to support the human return to the Moon with the Artemis missions, ongoing Mars missions, and other spacecraft across our solar system, including the Voyager spacecraft in interstellar space.
Yes, and a bit of good news, Voyager 2 is doing science again.
Yes, I think it was feeling a little bit lonely out there and decided in February to have a small anomaly on board the spacecraft, which actually delayed the start of the original project that we were going to do with the antenna, but actually gave us a little bit more time in preparation. So it all worked out well in the end. Voyager's back online and we're ready to go.
Exactly. What are the upgrades that have been carried out to the dish?
So with the antennas, we've been operating the same receiver equipment, the prime receiver equipment, for about 40 years on that antenna. And so as technology has improved all the time, we've had to make various adjustments, but now it's time for this larger upgrade with the replacement of both the X and the S-band transmitters on the antennas to a much more more higher power system that we can tune for various spacecraft across the solar system. So the new one of the new transmitters is about a 100 kilowatt transmitter. We're currently using a 20 kilowatt transmitter, and that just allows us to do that particular power output. So with this new 100 kilowatt transmitter, we can vary the output between that sort of 20 up to 100 kilowatt, which actually allows us to communicate quite easily with any of the spacecraft right across the solar system and beyond.
Does that let you draw more data from the spacecraft or supply more data to the spacecraft, or is that still dependent on what the spacecraft itself can achieve?
Yes, certainly it requires what output that the actual spacecraft can do. So if we think about the way we communicate on Earth today, a lot of internet or Wi-Fi, we're probably communicating at a few tens, maybe 100 megabytes per second. It's your fastest broadband sort of speeds worldwide. We'll get a spacecraft, say, like a mission at Mars, that might be only transmitting at a few megabytes or less per second. And something like Voyager, now over 22 billion kilometres away, well outside in the interstellar space outside of the solar system, it is only transmitting at about 140 bits per second. So not even bytes. So it's a very long and slow conversation, but still a good one with these spacecraft.
Good old days.
Yeah, so right down in the very early sort of modem days with that sort of spacecraft.
A long time ago.
Yeah, it won't allow us to get the data back any faster, but actually some improvements to the way we do the receiving and the processing will actually allow us to smooth through the data. So we're moving more into the sort of digital era of spacecraft communication, and the way we can actually store and process that information gets it to the scientists faster, a little bit cleaner with less interference, noise, disturbing that valuable data stream.
With the 70-metre dish being down for 11 months, does that put a lot of extra strain on the other, 3 34-metre dishes?
So, yeah, well, particularly with something like the Voyager spacecraft, because our 70-metre antenna is the only one in the world that has capability to transmit commands to the Voyager 2 spacecraft. And that means that any work that it does with Voyager, any work that it does with any of our other spacecraft across the solar system, or like the New Horizons spacecraft out there in deep space, we will have to actually move that workload over to the other 34-metre dishes and using, say, 2 34-metre dishes to supplement what would have been one 70-metre antenna just to receive data from the Voyager 2 spacecraft. And some of the work will also be offloaded to the other 70-metre antennas in our network, the other 2 sister stations in Madrid, Spain and Goldstone, California.
You were talking earlier about S-band and X-band. What does that actually mean?
So the various spacecraft operate at different frequency sets. So X-band is very common for a lot of spacecraft, as is S-band. But we're constantly moving to higher and higher frequencies. So if you imagine the Voyager spacecraft, they're sort of in the X-band, S-band for some of our other missions that are out there a little bit closer to home. As other spacecraft have been heading out there, venturing and wanting to get higher data rates back, we move into higher and higher frequencies, into the Ka-band frequencies. So the same way as you might tune your radio at home to listen to various radio stations across the AM and FM bands, we're sort of moving right through those frequencies with X and S and K bands.
And a lot of the communication satellites use Ka, Ku bands.
Absolutely, yeah. Those spacecraft that orbit around the Earth use those high frequencies to get those higher data rates back home.
That's Glenn Nagle from NASA's Deep Space Communications Complex near Canberra. And this is SpaceTime. I'm Stuart Gary. Still to come, a whole new generation of European launch vehicles about to fly. And later in the science report, claims that some 42,000 people have now died in Wuhan from the COVID-19 virus, rather than the 3,300 being claimed by Beijing. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
2020 is expected to be a big year for the European Space Agency, which is preparing to undertake maiden flights for both its new rocket launch systems, the Ariane 6 and the Vega-C. Ariane 6 will replace the existing Ariane 5 heavy lift launcher. The new design will allow quicker assembly and lower production costs, meaning twice the number of missions can be flown each year, while at the same time, launch costs will be reduced by half. The Ariane 6 design follows on from the existing Ariane 5. The core stage will use a single liquid hydrogen and liquid oxygen fueled Vulcan 2.1 engine. That'll replace the old, more expensive Vulcan 2 engine used on the Ariane 5. The new Ariane 6 is designed to be fitted with either 2 or 4 of a new design solid rocket booster known as the P120. These same P120 SRBs will also form the first stage of the new Vega-C launch vehicle. The Ariane 6 upper stage will use a single Venice liquid hydrogen and liquid oxygen fueled engine. The Ariane 62 version, the one using just 2 solid rocket boosters, will be capable of placing 10,350 kilograms into low Earth orbit and 5,000 kilograms into geostationary transfer orbits. Now, by comparison, the existing Soyuz 2, which is currently used by Arianespace under agreement with the Russian Federal Space Agency Roscosmos for medium-lift missions, can carry between 7,000 and 8,200 kilograms into low Earth orbit, depending on its configuration, and just 3,250 kilograms into geostationary transfer orbit. It's believed the Ariane 62 could begin replacing Soyuz flights from next year. Meanwhile, the Ariane 64 version, using 4 solid rocket boosters, will be able to lift some 21,500 kilograms into low Earth orbit and 11,500 kilograms into geostationary transfer orbit. By comparison, the existing Ariane 5 ECA, which it will replace, can lift 20,000 kilograms into low Earth orbit. That's slightly more than the Ariane 6, but only 10,865 kilograms into geostationary transfer orbit. The other new rocket to launch this year will be the Vega-C. It'll replace the existing Vega launch system. Vega is designed to lift payloads of up to 2,500 kilograms into orbit. It uses solid rocket engines for the first 3 stages and then a liquid-fueled engine for its 4th stage. The new Vega-C version will replace the existing P-80 first stage engines with the same P-120 solid rocket booster used for the Ariane 6. The current Zefiro 23 second stage will be replaced by a new solid rocket motor. At this stage, the existing Zefiro 9 third stage and the Avum 4th stage will be retained. Introducing a new rocket is always daring. Introducing 2 in the same year is absolutely stunning. This report from ESA TV.
Trucks arrive with the first and second stage of Ariane 6 at the Launcher Assembly Building in Kourou. Here, both stages are assembled horizontally before being transported to the mobile gantry for further integration. This is the process each Ariane 6 will go through. This simplifies the preparation process, just as in a car factory assembly line, and soon it will be put into practice at Europe's spaceport. The construction of the new launch base for Ariane 6 is in its finalisation phase. On one side, the launcher assembly building, and then the launch pad itself, with the big mobile gantry. Here, Ariane 6's boosters and fairing with payloads will be fitted. Ariane 6 facilities are taking shape. Europe's future launchers are becoming reality.
So first Ariane 6, the development goes full speed ahead, and now industry has started the production of the first 14 launchers of Ariane 6 in addition to the maiden flight. So 15 launchers in production today. On Vega-C side, all engines are tested, and we had the test of the Zefiro 40, which was the last engine test. So now we are really on the final path toward the maiden flight of Vega-C as well.
Vega-C is the new and enhanced version of Europe's lightweight launcher Vega. It will allow for an increased and versatile payload capacity from Kourou. In parallel, ESA is supporting the development of a structure to launch multiple satellites called Small Spacecraft Mission Service. This dispenser allows more than a dozen small satellites to be launched under the fairing of Vega and then Vega-C, which will soon launch from Kourou for the first time.
We will have a proof of concept flight on Vega, allowing to launch light satellites, a big number of small satellites. And we are already now preparing the same for Vega-C and Ariane 6. So all our European launchers, which are in development today, will have the capacity to offer launch of a number of small satellites, light satellites. It's a real market enhancement.
Another project for ESA is Space Rider. It is the continuation of the Intermediate Experimental Vehicle, IXV, the successful mission that flew in February 2015. Space Rider is an unmanned orbital vehicle that should provide Europe with its first operational reusable space transportation system. It will be able to return from space and will allow for experiments in microgravity, in-orbit validation of technologies, deployment of small satellites, and might even be used for Earth observation applications or servicing missions.
We have today the access to space component, which is covered through Ariane 6 and Vega-C. We are developing at ESA STS Space Transportation also propulsion elements, engines for transport in space, and with Space Rider we have an operational capability which will have to be decided for returning from space on Earth.
Today, with its range of launch vehicles, Europe is already able to launch any type of satellite into any orbit. The new portfolio under development aims to further secure this approach on the commercial launcher market and at the same time ensures Europe's independent access to space in the future.
The future of our transport capacities as such will depend on a number of technology bricks. So it's not about the idea of predicting what will be the overall system in 10 or 15 years from now. It is about replying to requirements. And some requirements are calling for new propulsion systems. This is why we put a first priority on propulsion systems, meaning engines. Engines for accessing space, and here it is important that we also take into account the reusable dimension of these engines, and for this we need to take into account the propellant, like you can tank your car with gas oil or other propellants. We will now work on propellants which are, for example, methane-based, allowing to reuse these engines for access to space. Structure means material. Material means weight. So there is a big change that we are doing much more also in carbon fiber for different elements of the launcher, which will automatically lower the overall weight. And if we lower, for example, 1 kilogram on the upper stage of a launcher, you have immediately 1 kilogram of wind for your payload, for your satellite. Today, we are introducing in Ariane 6 and Vega-C parts produced through ALM, 3D printing. Tomorrow, we will have much more. So we are also investigating not only on what are the technology building bricks of tomorrow, but also how we will produce launchers and launch solutions, transport systems tomorrow.
And that's ESA's Director of Space Transportation, Daniel Neuenschwender, ending that report from ESA TV. And this is SpaceTime. Still to come, a new mission to study giant solar particle storms. China launches 3 new spy satellites. And later in the science report, discovery of a new species of velociraptor in New Mexico. All that and more still to come on SpaceTime. NASA has selected a new mission to study how the Sun generates and releases giant space weather events known as solar particle storms. Not only will such information improve science's understanding of how the solar system works, but ultimately it will help protect astronauts travelling to the Moon and Mars by providing better information on how the Sun's radiation affects the space environment they're travelling through. Solar particle storms, sometimes called solar proton events, occur when particles, mostly protons, emitted by the Sun become accelerated either close to the Sun during a solar flare or in interplanetary space by shock waves from coronal mass ejections. These proton events can include a range of other nuclei such as helium ions and HCE ions. HCE ions are high-energy nuclei components of galactic cosmic rays, which have an energy charge greater than +2. The abbreviation HCE comes from H for high, Z from the atomic number, and E for energy. They include the nuclei of any element heavier than hydrogen, which has a +1 charge, or helium, which has a +2 charge. Each HCE ion consists of a nucleus with no orbiting electrons, meaning the charge on the ion is the same as the atomic number of the nucleus. Solar protons normally have insufficient energy to penetrate the Earth's magnetic field. However, during unusually strong solar flares, protons are produced with sufficient energies to reach the Earth's magnetosphere and ionosphere around the north and south poles. Now, protons are charged particles and are therefore influenced by magnetic fields. When energetic protons leave the Sun, they preferentially follow, or more likely are guided by the Sun's powerful magnetic field. Now, when these solar protons enter the Earth's magnetosphere, where the magnetic fields are stronger than the solar magnetic field, they're guided by Earth's magnetic field into the polar regions, where the majority of Earth's magnetic field lines enter and exit. Energetic protons that are guided into the polar regions will then collide with atoms and molecules in the atmosphere, releasing their energy through the process of ionization. The majority of this energy is extinguished in the extreme lower region of the ionosphere at altitudes of around 50 to 80 kilometres. The thing is, this region's especially important for ionospheric radio communications because it's where most of the absorption of radio signal energy occurs. And the enhanced ionization produced by these incoming energetic protons increases the absorption levels, which can have the effect of completely blocking out all ionospheric radio communications through polar regions. Even more severe proton events can occur during geomagnetic storms and can cause widespread disruption to electrical power grids. NASA's new mission, called the Sun Radio Interferometer Space Experiment, or SUNRISE, will use a constellation of 6 CubeSats operating as a single large radio telescope interferometer. The $62.6 million mission will be run by NASA's Jet Propulsion Laboratory in Pasadena, California, and should see SUNRISE launch in July 2023. The mission's 6 solar-powered CubeSats, each about the size of a toaster oven, will simultaneously observe low-frequency radio emissions from solar activity and then send that data back to Earth through NASA's Deep Space Network. The constellation will fly within 10 kilometres of each other, well above Earth's atmosphere, which would otherwise block out the radio signals SUNRISE wants to detect. Together, these 6 CubeSats will create three-dimensional maps pinpointing where giant particle bursts originate on the Sun and how they evolve as they expand outwards into interplanetary space. The data will help determine what initiates and accelerates these giant jets of radiation. SUNRISE will also provide the first ever map of the pattern of magnetic field lines extending far out into space from the Sun. This is SpaceTime. China has launched another 3 Yaogan 30 signet intelligence-gathering reconnaissance satellites. Beijing's describing the spacecraft as being part of a remote sensing test program studying the electromagnetic spectrum, or as being intended for scientific research experiments, land survey, crop yield assessments, and disaster monitoring. Of course, none of that is true. In reality, they're the latest members of a vast and ever-growing constellation of Chinese spy satellites. At least 64 of these eyes in the sky have so far been launched as part of the program, with Yaogan 33 being the only known launch failure and Yaogan 1 suddenly exploding in orbit for unknown reasons, most likely some internal failure. This massive fleet of spy satellites includes at least 18 optical imaging surveillance satellites, more than 8 terrestrial synthetic aperture radar imaging reconnaissance satellites, and over 29 electronic signals intelligence gathering satellites. The electronic signals intelligence gathering satellites are usually launched in groups of 3 and then deployed in orbit close together so they can fly in formation separated by just a few tens of kilometres. This allows them to triangulate and precisely pinpoint the exact location and source of an electromagnetic signal. But the sheer number of spy satellites being launched by China also suggests that it's going for a very high revisit rate, meaning they want to ensure more passes over specific areas of interest, thereby providing uninterrupted coverage of that region. This latest batch of 3 were launched aboard a Long March 2C rocket from the Xichang Satellite Launch Center in southwestern China's Sichuan province. However, previous launches have also taken place from both the Taiyuan and Zhuquan satellite launch centers. Built by the Chinese Academy of Sciences, these spacecraft are placed into 592 by 601 kilometre high orbits. And that's also really interesting, Because while 600-kilometre high orbits are good for imaging satellites to improve their resolution, signals intelligence gathering satellites are usually placed into higher orbits, usually over 1,000 kilometres above the ground, so they can get better coverage over a wider area. You're listening to SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a Science Report. Britain's Daily Mail newspaper and Radio Free Asia are reporting claims by Wuhan locals that some 42,000 people have so far died in the province from the COVID-19 coronavirus. The figures from local funeral home operators are based on the number of funeral urns being purchased. The news contradicts the official Chinese Communist government claims of just 3,300 deaths from just over 50,000 infections. Chinese Communist Party and government officials are already under growing international pressure for covering up the deadly virus and allowing it to spread globally. It's now been revealed that the first reported death from COVID-19 occurred on November the 17th. A report in the South China Morning Post claims the first case of someone suffering from COVID-19 was a 55-year-old from Hubei province, with up to 5 new cases reported each day and more than 60 confirmed cases from the outbreak by December 20. However, the Chinese government didn't alert the World Health Organization of the outbreak until December 31st. And Beijing didn't publicly admit human-to-human transmission of the virus until January the 21st. By which time thousands of people had already travelled from the area to the rest of China and from there across the world. The thing is, getting accurate information about what really happened and when has been difficult, because local doctors who do speak out are quickly arrested, and at least 5 and possibly as many as 8 have suddenly died from the virus, and one, Ai Fen, has simply vanished. Meanwhile, journalists trying to report on the spread of the disease in Wuhan are simply disappeared. Doctors say the number of intensive care patients with COVID-19 in Italy increased exponentially, doubling over 2 to 4 day intervals for up to 18 days. The findings, reported in the Journal of the European Society of Anesthesiology, showed this exponential increase then began to plateau out on March the 18th, becoming a more constant rate of increase for the next 3 to 4 days. Patients that survive the infection are spending an average of 15 days in intensive care. Meanwhile, a new study in the Lancet Medical Journal claims the latest hospitalisation and death rates from COVID-19 in mainland China suggest that nearly 1 in 5, that is 20% of people over the age of 80, are likely to require hospitalisation compared to just 1% of people under 30. The findings are based on a study of 3,665 cases. The data has shown a drop in the mortality rate over time, from the original 3.4% of those infected with COVID-19 down to around 1.38% now, although that could be due to the most vulnerable already having succumbed to the disease. Paleontologists have discovered a new species of Dromaeosauroid, a family of small to medium-sized feathered carnivorous dinosaurs related to velociraptors. The findings, published in the journal Scientific Reports, helps fill some missing pieces in researchers' understanding of dinosaur evolution during the late Cretaceous period, some 68 to 70 million years ago. The sparse fossil record of Dromaeosauroids indicate the group was still diversifying at the end of the Cretaceous period prior to the asteroid mass extinction event 66 million years ago, which wiped out 75% of all life on Earth, including the non-avian dinosaurs. Paleontologists have unearthed 20 identifiable skeletal elements of the new reptile at a dig site in New Mexico. The dinosaurs being named Dinobellitor, not Hesperus, from the Navajo word Dine, meaning Navajo people, and the Latin word Bellator, meaning warrior. The authors say the new species has a number of unique features, including vertebrae near the base of the tail that are curved inwards, which could have increased Dinobellitor's agility, both helping it catch food and possibly also helping it escape larger dinosaurs that wanted to catch it. However, gouge marks on the fossil's sickle-shaped claw suggest it wasn't always successful, and it lived in a tough neighbourhood, the injury possibly being inflicted by another Dinobellitor or some other theropod, such as Tyrannosaurus rex. And in case you were wondering, the velociraptors you saw in the Jurassic Park movies were an extreme exaggeration. In reality, they weren't much bigger than turkeys. Australia's longest continuous cliff line, which runs along the southern edge of the Nullarbor Plain facing the Great Southern Ocean, may be the longest cliff in the world. The 820-kilometre-long cliff, which researchers have named the Great Southern Scarp, includes both the Bunder Cliffs in South Australia and the Baxter Cliffs in Western Australia. Scientists looked at how the cliff formed and found that its unusual length comes from a combination of processes which may make it globally unique. The authors say that if the Great Southern Scarp is the world's longest unbroken cliff line, its geoheritage value would likely have an international level of significance. You can read their findings in full in the Australian Journal of Earth Sciences. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.